Yes, welcome back to the channel and hope all of you are doing great well today. आज हामी बिसिए फोर्थ सेमिस्टरको एउटा सब्जेक्ट पढ्नेछौँ है बिसिए यहाँ नोट्स नेपाल ओके आई विल सर्च द्याट इन्फर्मेसन ओभर इन्टरनेट है आएको छ ओके हामी चाहिँ फोर्थ सेमिस्टरको हो फोर्थ सेमिस्टरको कुराहरू पढ्नेछौँ ट्याब चाहिँ पेज चाहिँ न्यू ट्याबमा ओपन भएको छ स्क्रिप्ट ल्याङ्ग्वेज नोट नोट स्क्रिप्ट ल्याङ्ग्वेज इक्जाम प्रिपरेसन रहेको रहेछ फोर्थ सेमेस्टर लास्ट मोमेन्ट इक्जाम स्टडी पर्पज बिसिए ओएस अपरेटिङ सिस्टम पढ्नेछ ल्याब रिपोर्ट आइसक्यो डिबिएस इक्जाम प्रिपरेसन नोट फोर्थ सेमेस्टर यो हेर्छौँ यसलाई चाहिँ हामी एक्सपान्ड गऱ्यौँ है डेटाबेस म्यानेजमेन्ट सिस्टम फर एन्ड्रोइड एप्लिकेसन फ्रम प्ले स्टोर बिसिए नोट्स नेपाल ल्याएको छ बिसिए नोट्स नेपाललाई धेरै धेरै धन्यवाद Introduction to DBMS Database Management System is a software package designed to define, manipulate, and retrieve and manage the data in the database. The DBMS generally manipulate the data itself, the data format, field name, record structure, and the file structure. It also defines the rules to validate and manipulate this data. The DBMS retrieves the users of framing program for the data maintenance for generation query language such as SQL are used along with the DBMS package to interact with the database. Some of other DBMS example include MySQL, SQL Server, Oracle, DBX, Foxpro, MSSS database. Database is the collection of the information that is organized so that it can be easily accessed, managed, and updated. Data is organized into the row, column, and the table, and it is indexed to make it easier to find the relevant information. Characteristic of DBMS provide security and remove redundancy, duplication, insulation between the program and the data abstraction support multiple view of the data, sharing of the data, and the multi-user transaction for processing. DBMS allow the utility and the relation among them and the form a table. It follow the ACID ACID concept, automaticity, consistency, isolation, and the durability. DBMS support a multi-user environment that allows the user to access and manipulate the data in the parallel. DBMS multi-user access it does not support the multi-user access designed to fulfill the need for the small and the large business. It also limited the smaller DBMS system, remove redundancy and integrity. Redundancy and the integrity issue expensive but not the long-term total cost. Ownership is cheap. It is cheaper, easy to implement complicated transaction. No support for the complicated transaction objective of the DBMS element, the redundant data make access to the data for the user, provide the mass storage of the relevant data, protect the data from the physical harm and non-authorized person, allow for the growth of the database system, make the latest modification to the database availability immediately, allow the multiple user to be active on a time, provide the prompt response to the user for the data importance of DBMS. The database management system is so important it manages the data efficiency and allow users to perform the multiple tasks with ease. The DBMS management system is to organize and manage the large amount of data and information with a single software application. Use of this system increase the efficiency of the business operation and reduce the overall cost. The database management system are important to the business and the organization because they provide the highly efficient method for handling the multiple types of the data. Some of the data that are easily managed with this type of system include employee record, student information, payroll, accounting, project management, inventory, and the library books. This system are built extremely versatile. Without the database management, the text tasks have to be done manually and take more time. Data can be categorized and structured to suit the need of the company for the organization. Data is entered into the system and accessed on the routine basis by assigned user. Each user may have an assigned password to gain access to their part of the system. Multiple user can use the system at the same time in the different way. Advantage of the DBMS. DBMS offers the variety of the technique and the store and retrieve the data. DBMS serves as an efficient handler to balance the need of the multiple application using same data. Application programmers never exposed to the details of the data representation and storage. DBMS uses the variety of the powerful function to store and retrieve the data efficiently and offers the data integrity and the security. The DBMS implies the integrity and the constraint to get the high level protection against the provided access of the area. The DBMS schedule the concurrent access to the data in such a manner that only one user can access the same data at a time. Redundant application development time. At disadvantage of the DBMS, cost of hardware and the cost of the DBMS is quite high, which increase the budget of your organization. The most of the database management system are often complex, so that the training for the users use the DBMS is required. In some organization, all the data is integrated into the single database, which can be damaged because of the electric failure, or the database is corrupted on the storage media. Use of the same program at a time may users sometimes lead to the loss of the some data. DBMS cannot perform the sophisticated calculation banking for the customer information, account activity, payment, deposit, loan, etc. Airlines for the reservation and the schedule information, university for the student course registration, college and the grade. Telecommunication, it helps to keep a call record, monthly bill and maintaining the balance. Finance for storing the information about the stock sales and the purchase of the financial instrument like the stock and the bond. Sales used for storing the customer product and the sales information. Manufacturing, it is used for the management and the supply chain for tracking the production of the item, inventory status in the warehouse. HR management for the information about the employee salary, payroll, deduction, generation, and the paycheck, etc. Unit double I, database design architecture model. Overviews of the database design process. Database design are designed to manage the large body of information. Database design mainly involves in the design of the database schema, the design of the complete database application environment that meet the need of the enterprise. Being model require attention to the broader set of issues. Index tech we focus initially on the waiting database query of the design of the database schema. Database design is a collection of the process to facilitate and design the development, implementation, and maintenance of the database system. It helps to produce the database system that meet the requirement of the user, have the high performance. Requirement collection and analysis. Conceptual database design. Choice of the DBMS. Logical database design, physical database design, implementation of high level data model. Provide the database designer with a conceptual framework which is to specify the data requirement of the database users and how the database will be structured to fulfill this requirement. Initial phase, the database design, then it is categorized fully data need of the prospective database user. The database designer need to interact extremely with the domain expert and the users to carry out this task. The outcome of this phase is the specification of the user requirement. The next, the designer choose the data model. By applying the concept of the chosen data models, translate this requirement into the conceptual schema of the database. The schema developed at this conceptual design phase provide a detailed overview of an enterprise. The designer review the schema to confirm that all the user requirements are in need satisfied and that are not conflict with one another. The designer can also examine the design and to remove any redundant feature. The focus at this point on describing the data and their relationship rather than on the specifying the physical storage details. In terms of the relational model, the conceptual design process involves the decision on what the attribute we can capture in the database and how to group this attribute to form the various tables. A fully developed conceptual schema indicates the functional requirement of the enterprise. In the specification of the functional requirement, user describes the kind of the operation transaction that will be performed on the data. Example operation data include modifying or updating the data, searching for and retrieving the specific data and deleting the data. At this stage, conceptual design, the designer can review the schema to ensure it meets functional requirement. The process of moving from a abstract data model to the implementation of the database proceed in the two final design phase, the logical design phase. The designer maps the high-level conceptual schema into the implementation of the data model of the database system that will be used. The designer use the resulting system-specific database schema in the subsequent physical design phase in which the physical feature on the database are specified. Database design for the university organization to illustrate the design process. Let us examine how the database for the university could be designed. The initial specification of the user requirement may be based on the interview with the database users on with the designer on analysis of the organization. The description that arises from the design phase serves as the basis for specifying the conceptual structure of the database. Here are the major characteristics of the university. The university is organized into the department, and each department is defined by the unique name. Department name is located into the particular building and has a certain amount of the budget. Each department has a list of the courses it offers. Each course has associated with the course ID. Instructor are defined by the unique ID. Each instructor has a name, associate, department name, and the salary. Students are defined by their unique the university maintain a list of classroom specifying the name of the building, room number, and the room capacity. The university maintains all the list of classes section taught. Each section is identified by the course ID, section ID, year, and the semester that associate with it. A semester, year, building, a room under, a time slot ID of the time slot when the class meets. The department has the list of teaching assignment specifying for each instructor. The section of the instructor is teaching. The university has a list of all the student course registration specifying for each student the course in the associate section that the student has taken, and the register for view data abstraction. The database system is a collection of the interrelated data in the set of program that allow the users to access and modify this data. The major purpose of the database system is to provide users with abstract view of the data. This system had the certain details of how the data are stored and maintained. For the system to be usable, it must retrieve the data efficiently. The need for the efficiency has led the design to use the complex data structure to represent the data in the database. Since the many database system users are not computer trained, developer hide the complexity from the users through the several level of abstraction to specify the user's interaction with the system. Physical level, the physical level, the lowest level of abstraction described how the data are actually stored. The physical level describe the complex how low level data structure are in detail. Logical level, the higher level of abstraction describes what the data are stored in the database and the what the relationship exists among those data. Database administrator who must decide what the information to keep in the database. We use the logical level of abstraction. View level, the highest level of abstraction, describe the only part of the entire database. Even though the logical level uses the simpler structural complexity remain because of the variety of the information stored. The large database many to access the database system and the database. The view level of abstraction exists to the simplify their interaction with the system. The system may provide many view for the same database. Data models, the collection of the conceptual tools for designing the data relationship, data semantic, and the consistency constant, and the data models provide the way to describe the design of the database and at a physical level and the view the level. The data models can be classified into the four different category. Relational model, the relational model is the collection of the tables to represent the both data and the relationship among those data. Is tables has the multiple column and each column has the unique name. Table are also known as the relation. Is table contain the record of the particular type. Each record type defines the fixed number of the field and attribute. The columns of the table correspond to the attribute of the record type. The relational data model is the most widely used model, and the vast majority of the current database system are based on the relational model. In the entity relational model, the entity relational model has a collection of the basic object called the entity. The entity among this object as an entity is a thing or object. The real world that is discriminable distinguishable from the other object. The entity relationship model is widely used in the database design of the object-based model, object-oriented programming, especially Java, C++, and the C has become the dominant software development methodology. And this lead to the development of an object-oriented data model that can be seen as an extending ER model with the notation in the encapsulation method in the object identity. The object relational data model combines the feature of the object-oriented data model and the relational data model. Semi-structured data model. The semi-structured data models permit the specification of the data or the individual data items of the same type may have the different set of attributes. The extensible markup language XML is widely used to represent the semi-structured data. Historically, the data model and the hierarchical data model ports in the relational data model. This data model were tied closely to the underlying implementation and the complicated tasks of modeling the data. As a result, they are used little now, except in the old database code that is still in the service of the some places. Database language. The database system provides the data definition language to specify the database schema and the data manipulation language to express the database query. And the update data manipulation language DML. Data manipulation language DML is a language that enables users to access or manipulate the data as an organized by the appropriate data model. Select it is used to retrieve the data from the database. Insert it is used to insert the data in the table. Update it is used to update the existing data within the table. Delete it is used to delete the record of the database. There are the basically two types. Procedural DMLS requires the user to specify what data are needed and how to get those data. Declarative DMLS, also referred as the non-procedural DMLS, requires users to specify what data are needed without specifying how to get those data. Data definition language DDL. Data definition language actually consists of the SQL command that can be used to define the database schema. It simply deals with the description of the database schema and used to create and modify the structure of the database object in the database. Example of the DDL command: create, it is used to create the database or the object like the table, index, function, view, store, procedure, and the trigger. Drop, it is used to delete the object from the database. Alter, it is used to alter the structure of the database. Truncate, it is used to remove all the records from the table including space allocated for the record are removed. Comment, it is used to add the comment to the data dictionary. Rename, it is used to rename an object existing in the database. Data control language DCL include commands such as grant and revoke, which mainly deals with the right of permission and the other control of the database system. Example of the DCL command: grant, give user access privilege to the database. Revoke, withdraw the user access privilege given by the grant command. Transaction control language TCL command deals with the transaction within the database. Example of the TCL command: commit a transaction, rollback a transaction in case of any error occur. Save point, save point with the transaction. Set transaction, specify the characteristic for the transaction. Query by the language QBE. Query by the language is a query language used in the relational database that allow users to search for the information in the table and field by providing the a simple user interface where the user will be able to input the example of the data. So he or she wants to assess the principle of the QBE is that merely an abstraction between the users and the real query that the database system will receive. The background of the user's query is transferred into the data manipulation language from such as SQL. In the SQL statement that will be executed in the background. QB is a method of the query creation that allow the users to search for the document based on the example in the form of the selected text string or in the form of the document. Because of the QB system formulate, QB can be throughout the fill in the bank method for the query creation. The object access query design grid A grid is an example to conduct the search for the field meta matching particular condition. The user enter the criteria into the form, creating the search condition for as many field as desired. The query is automatically generated to search the database for matching data. DBMS structure or DBMS system is parts it into the modules that deals with the reach of the responsibility in the overall system. The functional concept of the database system can be broadly divided into the storage manager and the query processor component. The storage manager is important because the database typically requires the large amount of storage space. The query processor is important because it helps the database system specify and facilitate the access to the data. A naive tailor agent, web user, application programmer, sophisticated users, analysis, database administrator, use application interface, application programmer, query tools, administrator tools, compiler, and the linker, DML, query, DDL, interpreter, application program, object code, query evaluation engine, DML compiler, and the organizational buffer manager, file manager, authentication and the integrity manager, transaction manager, data indicate, data dictionary, so statistical data, query processor. The query processor component include a DDL interpreter which interprets the DDL command and record the definition in the data dictionary. DML compiler which translate the DML statement into the query language into an evaluation plan consisting of the low-level instruction that are query evaluation and the engine understand. The query can usually be translated into any number of alternative evaluation plans that all give the same result. The DML compiler also perform the query optimization, that is, picks the lowest cost of evaluation plan among the alternative. Storage manager. A storage manager is a program module that provide the interface between the low level data stored in the database and the application program and the query submitted to the system. A storage manager is responsible for the interaction with the file manager. The storage manager component include authentication and the integrity manager which test for the satisfaction of the integrity constant and check the authority of the users to access the data. Transaction manager which ensure that the database remains in the consistent correct state despite the system failure and the concurrent transaction execute proceed without conflicting. File manager which manage the allocation of the space on the disk storage and the file structure used to represent the information on the stored disk. Buffer manager which is responsible for fetching the data from the disk storage into the main memory and deciding what data to cache in the main memory. The buffer manager is a critical part of the database system since it enables the database to handle the data size that are much higher than the main memory. Transaction manager. A transaction manager is a collection of the operation that performs the single logical function into the database application. Each transaction is a unit of the atomicity and the consistency. Thus, we require that the transaction do not volatile any database consistency constant. That if the database was consistent, so when the transaction started, the database must be consistent. So when the transaction successfully terminate transaction, the manager ensures that the database remains in the consistent correct state despite of the system failure. Example, the power failure and operating system crashes in the transaction failure. DBMS architecture helps in the design, development, and implementation and maintenance of the database. The database stores the critical information for the business. Selecting the correct database architecture helps in the quick and the secure access of the data. Tier architecture. The simplest database architecture are the tier 1 where the client server and the database all reside on the same machine. Anytime you install the DB in your system and access to it to the practice SQL query. It is a tier 1 architecture, but source architecture is rarely used in the production. Two-tier architecture. Two-tier architecture is a database architecture where the presentation layer runs on the client PC, mobile tablet, etc. Data is stored on the server. Tier 2 architecture presentation layer runs on the client PC, tablet, etc. Data is stored in the server. Client 1 database, client 2, client 3. an application interface, which is called the ODBC, Open Database Connectivity, and API, which allow the client-side program, is called the DBMS. Today, the most of the DBMS offer the ODBC drive. For the DBMS, two-tier architecture provide the added security to the DBMS and is not exposed to the end user directly. Three-tier architecture client server database. The three-tier schema is an extension of the two-tier architecture. Three-tier architecture at the following layer: presentation layer, your PC, tablet, mobile, etc. Application layer, server, database server. The DBMS architecture contains an application layer between the users and the DBMS, which is responsible for communicating with the user request and the DBMS system and send response to the DBMS to the user. Mm, the application layer, business logic layer also pursues the functional logic constant and the raw rules before the passing the data to the users or down to the DBMS. Three-tier architecture is the most popular DBMS architecture. The goal of the three-tier architecture is to separate the user application and the physical database. First one to support the DBMS characteristic program data independence, support the multiple view of the data. Example of the three-tier architecture is any large website on the internet. Data independence, the main purpose of the data abstraction is achieving the data independence in order to save the time and cost required when the database is modified. At older data independence is the ability to make the changes to the data characteristic without they have to make changes into the program that assess the data. It is important because of the saving of the time potential error caused by reducing the modification to the data assets and the software physical level of independence. It refers to the characteristic of being able to modify the physical schema without any alteration to the conceptual logical schema. This alteration or the modification to the physical structure may include utilizing the new storage devices, modifying the data structure used for the storage, altering the indexes, or using the alternative file organization technique. Local level data independence, it refers to the characteristic of being able to modify the logical schema without affecting the external schema or the application programmer. The user view, the data will not be affected to any changes to the conceptual view of the data. This change may include the insert and deletion of the attribute, altering the table structure, entity, or the relationship to the logical schema, etc. The ER model basic concept. The ER model defines the conceptual view of the database. It works around the real world entity and the association among them. At the view level, the ER model is considered as a good option for designing the database entity relationship program, also known as the ERD or the ER diagram or the ER model. It is the type of structural diagram for use in the database design, and ERD contains the different symbol and the connector that visualize the two important information, the major entity within the system scope with the interrelationship among this entity as student ID, student name, student address, student name, college ID, college name. Component of the ER diagram: entity, weak entity, attribute, key, composite, multi-value, derived relationship, one to one, one to many, many to one, many to many. ER model concept component of the ER diagram: rectangle represent entity set, ellipse attribute, diamond relationship set, line they link the attribute to the entity set and the entity set to the relationship. Double ellipse multi-valued attribute, or dash ellipse or derived attribute. Double rectangle weak entity set, a double line total participation of the entity in the relationship set. Entity and ellipse, an entity is an object component of the data. An entity is represented as a rectangle in an ER diagram. For example, in the following ER diagram, we have the two entity, student and the college. These two entity have many to one relationship, as if many student of college in the study in the single college. We read more than one relationship later. For now, and the focus on the entity student study college. Weak entity, an entity that cannot be uniquely identified by its own attribute and rely on the relation with other entity, is called the weak entity. The weak entity is represented by the double rectangle. For example, a bank account cannot be uniquely identified without knowing the bank to which the account belongs to. So the bank account is quickly weak utility. Bank account, bank attribute, An attribute describes the property of an entity. An attribute is represented as an oval in the ER diagram. There are the four types of attribute: key attribute, composite attribute, multi-valued attribute, derived attribute, roll number, name, age, address, student. Key attribute can uniquely identify as an entity from the entity set. For example, student roll number can uniquely identify a student from the set of the student. Key attribute is represented by the oval, same as the other attribute. However, the text of the key attribute is underlined. Composite attribute, an attribute that is the combination of other attribute, is also known as the composite attribute. For example, in student entity, the student address is a composite attribute, as an address is composed of other attributes such as the pin code, state, country. Student address, pin, state, country. Multi-valued attribute, an attribute that can hold multiple value, is known as the multi-valued attribute. It is represented with the double value in the ER diagram. For example, a person have the more than one phone number, so the phone number attribute is multi-valued. Derived attribute is one whose value is dynamic and different from another. Attribute is represented by the dashed oval in the ER diagram. For example, person age is derived as it changes over time, and it can be derived from another attribute. Date of birth. Relationship is represented by the diamond shape in the ER diagram, which shows the relationship among the entity. There are the four type of relationship: one to one, many to many, many to one, and many to many. Okay, this much for today. आज 31 मिनट भइसकेको छ। फेरि हामी अर्को विषयको पढ्नेछौँ है। अब यति कति सम्झिन्छ दिमागले जति टिप्छ टिप्छ। अब हजुरको महत्त्वपूर्ण समयको लागि धेरै धेरै धन्यवाद।